Perfect. Okay, so thanks everyone for making time for this session. And I must apologize ahead of time. I do have a little bit of a cold, so if I stuck with the occasional cough, you'll have to forgive me. My name, as I mentioned earlier, is John McKeever. I'm one of the co-founders and co-directors of Data Migrators. We're a Melbourne, Australia-based professional services company. That's Melbourne. You can see hopefully you can see my screen now, and that's where I'm speaking from now. And I'm joined by Larry Pinyatzik, Michigan-based MettleCI expert. And over the course of delivering our services to clients, we've been in existence as an organization for about a decade, but as a bunch of people who worked together before Data Migrators much longer. And over that period, we, like many people, developed opinions, tools, techniques about the best way to use DataStage for effective software delivery. And in particular, how to use DataStage within the context of a properly agile software delivery practice. And by agile, I don't just mean wearing jeans and using sticky notes. I mean proper agile, where we follow a lot of the agile philosophy principles. We track our team velocity. We use either Kanban or Scrum in order to execute our projects and keep track of them. And that's really what MettleCI is about. It was about our desire to deliver iteratively, quickly, efficiently and transparently to our customers. MettleCI we delivered for our own use, and over time it became something that our clients wanted to use, to the point now where the majority of our business is actually now in putting MettleCI into the hands of large financial institutions, insurance, retail organizations all around the world. So I'm not going to labor the slides today. I just want to give you a little bit of context. MettleCI really is about supporting the Agile Manifesto. If you look at the first three principles, for example, they're all about the early and ongoing absorption of change into your software delivery lifecycle. And that bottom one particularly, deliver working software frequently. Two keys there are working and frequently. Okay, so we want to remove any impediments to pushing software downstream in our delivery cycle. That's really about automated build and delivery of DataStage solutions, but also to test that software we're throwing downstream qualifies for expensive and slow and sometimes error-prone humans to get involved. A lot of software that we build in other technologies, not DataStage, relies on expectations about a software delivery tool chain that provides automated deployment, automated testing, and that's what we're really bringing to the MettleCI, to the DataStage landscape with MettleCI. And so, as your solutions get more and more complex over time, the number of connections between your different software components increases, the complexity of those solutions increases, the effort to deploy them increases, the effort to test them increases, and so the actual cost of change in your system, solution increases over time. And MettleCI is about flattening that, using continuous delivery, using small frequent changes, and reducing that feedback loop. The software developer should know within minutes whether the change they've made is effective, whether they've broken a build, whether they're still adhering to software delivery practices and organizational coding standards. And so in a headline, MettleCI is about, if I was to give you one nugget about what it does, is it shortens your cycle time. To take an idea or a defect from its inception or identification through build, test, and deployment and delivery into production. That's what MettleCI is about. It's putting that software delivery pipeline on rails. I'll obviously make these slides available to you after the call. So I'm not going to labor the benefits of a modern software delivery lifecycle that relies on automation. But of course, TCO is what it's fundamentally about. It's about removing all of the manual error-prone labor that people often get involved in deployments, and automating everything that can be deployed and getting people to focus on stuff that people are good at. The way we deliver all of these benefits in Mettle is through the following features and functions. And what we're going to do today is very shortly, I'll get off slides and we'll spend our time looking at working software. And I'll go through each of these features and functions for you. Just a heads up, when I do that, when I do the demo, I'll probably go for, so today we're going to do a demo on Jenkins, which is pretty kind of slick and easy. So I guess I'll talk for about 40 minutes, maybe 45 minutes. And there'll be plenty of time for questions at the end. Over the course of doing seriously hundreds of these demos, we found it far better if you guys wouldn't mind sticking all of your questions into the chat. If I could go interrupted, that would really help the demo flow smoothly. And I know you'll have burning questions, and oftentimes I'll answer those questions with the next part of the demo. And the demo will try to cover all of the major features and functions. Yes, if you could stick them into the chat window, Larry, I know will be active on chat and answering those as we go along. And we'll also do a review of the questions at the end to see if there's anything we need to pick up. So, MettleCI features and functions that we're going to see today. As a freelance DataStage developer many years ago, I would often go from one customer site to another, and they would often present me with what was often called a peer review checklist, which were effectively kind of organizational coding standards. And those coding standards were frequently pretty light, of questionable value, often not more than maybe 2 or 3 pages, that focused on things like coding naming standards and stuff like that. If I was building a solution in C or C++ particularly, I would be accustomed to using a tool called lint. And what lint does is it performs static code analysis. That is the analysis of your source code, not executing it, but just an analysis of your source code. And lint would identify anti-patterns in your code. It would look for bad coding practice, impediments, characteristics of your code that present impediments to portability between environments, that might represent security vulnerabilities, that might just represent patterns in your code that as an organization, for whatever reason, you've decided you don't want. And what we've done with our compliance tool is we've brought that to the information server landscape. So now you can test your DataStage jobs for adherence to coding standards, and MettleCI ships with a library of coding standards, which is fully configurable. It's just a starting template for you to adopt, adapt, throw out the rules you don't want, create your own rules. And we'll have a look at how we use that, and also a couple of the rules later on as well. Unit testing. So one of the keys to MettleCI, and that's where the CI comes from, is continuous integration, is unit testing. So if I was developing some software in Ruby, for example, I would be accustomed to using a tool called Cucumber, which uses a grammar called a YAML-based grammar called Gherkin to define automatable test cases on my Ruby solution. And what we've done is, with our automated testing solution for MettleCI, we've kind of borrowed some of those concepts. And so you can create a unit test for a DataStage job. And also alongside the unit test specification is to provide some unit test data. And importantly, that unit test can be automatically generated, either by using button clicks on a web interface like you'll see me do today, or en masse for an entire project using a command line. So today I'll automatically create a unit test for a DataStage job. I'll massage that unit test with some data, some extra test data, and we'll execute unit tests. And then I will check that job and its unit test specification and its test data into Git. And it will get shipped downstream. We're compatible with every flavor of Git for jobs and unit tests, and you can obviously check your other non-DataStage assets into your Git repository as well. MettleCI maintains the structure of your Git repository, so you don't need to worry about that. Today I'm going to use Atlassian Bamboo as the interface over a Git repository, but that's largely irrelevant. And a lot of people say, hey, John, we want to use MettleCI because we want to use DataStage with Git. And a lot of people seem to think that Git is just a digital bookshelf, like a vault where you keep software. And that's not really the role of Git. The Git is a staging post for continuous integration, and the output of a continuous integration run is a release, which is effectively a snapshot of your Git repository at a point in time where continuous integration succeeded. And at that point, you can say, okay, that snapshot, that release is then something we can push downstream. And so today we're going to look at some, we're going to look at continuous delivery into a QA environment. So what that means is that as soon I'm going to check into Git, it's going to automatically invoke my continuous integration process. Today we're going to use Jenkins to orchestrate that. And then hopefully my continuous integration process will be successful, and then it will automatically deploy into a QA environment. So we have continuous delivery into our QA environment. We then have automated delivery into two other downstream environments, performance and production. We're calling them today. And the difference between continuous delivery and automated delivery is that automated delivery involves humans approving that release process. So we'll have a look at all of that. You'll see two halves of MettleCI, or you will experience two halves of MettleCI, that you'll only really see the interactive side of things. So we'll start with a work item that gives me a piece of work to do. We'll use Atlassian Jira for that. I'll then go into the DataStage Classic Designer on 11.7 I'm going to use today. And I'll modify my DataStage job. We're also compatible with the browser-based designers. And I say designers, you've got, obviously in 11.7, you've got the data flow designer, and then you've kind of got imminently being released the new common in IBM Cloud Pak for Data, the new common canvas Elira editor, which is fantastic. If you haven't seen that, I'd encourage you to take a look at that. So I'm going to modify my job in DataStage 11.7 with the classic Windows-based designer. I'm then going to run some code compliance, which is that kind of lint-like static code scanning using a library of rules that ship with MettleCI. I'm then going to build a unit test, which is that system we've got that's kind of modeled on Ruby Cucumber. I'm then going to check into Git, which will then trigger CI in Jenkins. And if that's successful, automatically deploy into downstream environments. So you'll be glad to know that's enough slides. I've got hundreds more slides, but I really actually want to get into some working code. So we're going to start here. This is my Jira board, and I'm going to assume that you're either using Jira or using something very similar to Jira in order to manage your work. I'm in a sprint, and this is sprint 1, which has been running now, I think, for about 4 years. This is our demo sprint. And today I'm going to take this piece of work in progress. So this is me, the orange-backed avatar, and I'm working on this problem. The tax amount calculation is incorrect in job TR orders. And I put Jenkins in brackets after this because all the Jenkins demos I associate with this story. We should also point out that MettleCI is also compatible with Azure DevOps, both cloud and local based, Atlassian Bamboo, GitLab, probably a couple of others that I've missed, but we provide example pipelines for all of these build systems. So I'm going to work on this tax amount calculation is incorrect in TR orders. If I look at the history, I can see that the developer or business analyst who's raised this story has done a really good job. They've put their assumptions about a tax calculation. They've provided some test data. So they're saying when I provide these input values, I expect a value of 12.76 to be calculated, but instead I'm getting 12.75. They've given me some SQL to verify in the end user database. I've got some comments here against the story, so some work's already been done. And if I scroll down to the development section here, I can see that 6 commits have already been made into the Git repository in support of this story. So these are the commits, including, I just moved house last week, so I just wanted to check my IP was all good. So I just ran a check last night from my new IP address. So that's the story. It's also done a great job of identifying the job I need to change, of course. So let's go on and fix that in DataStage. So this is my DataStage Designer client, and I don't really know anything about this job. What I want to do is I want to probably initially run that static code analysis. Is there any low-hanging fruit here? Are there any very obvious problems that might actually have a functional impact on my job? So maybe I've broken some coding standards and fixing those will actually improve the chances of my job functioning correctly. To do that, I'm going to use MettleCI. And alongside this designer client, there's another browser-based tool that we're going to use. Let's get to the right page. And this is the MettleCI workbench, okay? And this is our interface into MettleCI when using it in that interactive side of things. It provides access to 3 main functions to define and maintain unit tests and look at the results of unit tests, to run those compliance checks and monitor those, and then finally to check into Git, after which our CI process is invoked in Jenkins. That uses all of the behind the scenes MettleCI components, which is effectively a very rich suite of command line tools. If you've used the IS tool command for information server, MettleCI is kind of similarly modeled after that. There's a MettleCI command and then a whole suite of plugins that get installed in there that enable you to automate the deployment, the execution, rerunning compliance, rerunning unit testing. You'll see all of that when we go and have a look at our Jenkins plan in action. You'll see here, there's a button that says integrate with DataStage client, and I've already pressed that. And what that's done is installed into my designer client some new menu items. Okay, so I've got compliance, a unit test specification. So have a look at the unit test specification, have a look at the unit test results, and then finally commit to Git. And we've got a link to our online documentation there. I'll show you that later. So let me start by checking my job for compliance errors. So this has taken me back into the MettleCI workbench. It's already got my context, my asset name. So I'm going to run compliance. So what's happening behind the scenes here is MettleCI is exporting my job from the DataStage repository. It's loading it into an in-memory graph, and then it's going off to a Git repository, and that big long list of things that you saw coming down, all the rules that it was pulling, the coding rules that it was pulling out of the Git repository. And we actually ship all of these rules to you as a Git repository for you to edit. And you can see the results of this particular asset type, which is a parallel job. In a demo environment, I've got 38 coding rules that apply to parallel jobs. We also have rules for server jobs and for job sequences as well. Of the 38 rules, 32 have passed, but 6 have failed. So I'm just going to filter down on those. And the first thing to notice about these rules is that they're all classed as a status of failure. So compliance rules can have one of 2 statuses. They can either have warning or failure. So warning means that you've broken this compliance rule. However, when we run continuous integration, we will overlook that. We'll still report it as a rule that's been broken, but you can breach that rule without killing the CI process. You can still build releasable software that features that particular breached rule. So one of those rules might be there is a characteristic of your job which is not currently compatible with IBM Cloud Pak for Data, for example, or something else that's got a fairly kind of negligible consequences for the deployment of your job. However, all of these rules are classed as failure, which means any one of these rules will cause the continuous integration process to fail. So what we're effectively saying here is there is a code quality firewall. I cannot promote a job out of development that features these particular coding errors. So I've got to fix these before I can even think about checking my job into Git. Or certainly I can check my job into Git, but all that will happen is it will invoke a CI process, which will fail. So let's take each of these one at a time. The first one is that a file reference is missing a required parameter. So a particular data set in my job, DSEX orders, does not use the recommended parameter set. So as a team, we've decided that all data sets must use this particular parameter, P global dataset dir, as the root of all of its references. And also on the same data set down here, we can see that dataset DSEX orders uses a hard-coded path. So I'm not only am I not using the right parameter, I'm not using any parameter. I've got a fully hard-coded path to that data set, and it's in my home directory, which is going to be fine in development, but it's unlikely to be there in the QA environment, and definitely won't be there in the production environment. So let's go off and fix both of those two rules. Here's my QA, here's my data set, and we can in fact see that I've got hard-coded reference to my home directory. So let's get rid of that and replace it with the parameter that I should be using. Done. So I think I've fixed that problem. And when we rerun compliance in a second, we'll see if that's worked. I skipped over one problem here. An ODBC connector ODBC customer contains a hard-coded username, John, and a hard-coded password, albeit encrypted, but still hard-coded. Those should be parameterized. So if I jump into that ODBC stage, we can in fact see I've got hard-coded database credentials. So let's replace those with user ID. Let's replace that with my password. That's good. So down onto number 4, a lookup failure. So this lookup is configured to fail, which some people think is a good way to design a job. As a team, we've decided that we're going to handle lookup failures a different way, or we have some upstream mechanism for guaranteeing there will be no lookup failure. What I don't want is my job to fail for reasons based on data. So I'm going to set that continue. And again, that's not a rule you need to adopt. It's just something we supply with the compliance rule templates, and you can adopt that or adapt it or not as you see fit. So I think I've fixed that one. Stage naming, TRX city timestamp, which is a transformer, has an incorrectly formatted name, and it gives me the regular expression I should be following there. So in this case, it's probably not going to have big consequences, but certainly for source and target stages, stage naming is one of the things that Information Governance Catalog uses to help derive its understanding of lineage. So consistent naming across jobs can be useful there. And also it helps maintainability. And sorry, finally, one thing I should point out about stage naming is you can build stage naming rules based on not just the stage that's on the canvas, but also on the underlying orchestrate operator that the stage maps to. So that means if you have a join stage, you can just say all join stages need to start with J, for example, or you can actually say, if this join is configured as a left join or a right join or an inner join or an outer join, I can have different naming standards for each of those. So actually the name on the canvas can tell you what the in some cases, what the stage is actually doing. Finally, system time dependency. So the transformer TX calc amount uses a system clock function. Okay, so we're referencing the current time or current timestamp somewhere, and that should be replaced with a parameter or some kind of source data mapping. So what this is saying is that every time I run my job, because it's got somewhere a reference to the system clock, some aspect of my job is going to produce a different output every single time I run it. And that may well be the intention. It's likely to be the intention. However, it makes the job difficult to test or to build a repeatable test case for. So one thing I could do is I could create an automated unit test and say, these particular columns, which are being derived from the system clock, I will make them exempt from the test. And you can do that with MettleCI, but that's kind of losing out on some opportunity to have a test that covers all of the columns in our job. What would be better is if we were to parameterize that value and provide it at runtime. So what I mean by that is if I go into txcal command and I go down to this derivation here, I can say I'm referencing the current timestamp. What I could do is I could stick into there a job parameter and then provide the current timestamp as that job parameter. What I actually want to do in this case is actually map that from an input value. I'll replace that. All my windows are in the wrong place because I was on an enormous external monitor last night. Okay, so that's been replaced. So I think I'm just going to compile that. A quick note about compliance as well is that I could have just saved my job, and that would put my job into the XMeta repository and made it available for compliance. However, that would not work for compliance rules based on the contents of transformers. In order to get the transformer code generated, you need to actually hit the compile button. So now if I go back, I'm actually going to invoke compliance now from within the workbench. So I'm just going to go to the front compliance page and say new compliance check. It's still got my context, run compliance again. It will export that newly compiled job from the XMeta repository, load it into an in-memory graph. I've got my environment here configured to go off and refetch the rules every single time. And we can see now that I've got no compliance errors. So this job meets all of our organizational coding standards. There are no obvious coding problems. And there are no design aspects of my job which are going to cause continuous integration to fail. So that's great. So the next thing to do is to have a look at building a unit test with this job. So let's go to, actually just 1 second. I'm just going to make sure that I don't already have a unit test because I want to show you, I have one left over from last night, which I've just paused my share. Okay, pretend you didn't see that. So what we're going to do is we're going to have a look at the unit test for this job. So I'm going to go to Tools, Custom, Unit Test Spec. And it takes me to the workbench. It tells me that I don't have a unit test for this particular job. Do I want to create one? And I'll say yes. Go off, please, and create a unit test. So what that's doing behind the scenes is exporting my job from the XMeta repository, loading it again into that in-memory graph, and then it's doing a few smart things. And I will quickly go back to a couple of slides, but only just to illustrate a point. So what's happening is MettleCI is parsing the job, and it's identifying the source and target stages in my job. It doesn't matter what those stages are. They could be complex flat files, hierarchical stages, streaming stages, and it's reading the metadata definitions of those stages and creating skeleton CSV files, along with a test specification document that associates each one of those CSV files with its respective stage. So let's go off and have a look at what's been created. I'm going to edit this unit test, and here's the unit test editor. So here's our job, TR orders. Here's our specification, which is just by default named after the job. You can create multiple specifications and run different tests. And here are those CSV files listed down the left-hand side. And over here on the right is YAML test specification. So YAML is just a markup syntax. And what it's effectively doing is describing for each CSV file associated with an input stage, when I run my job with these conditions, then success is defined by these particular outputs containing data that looks like this CSV file. There's that ignore clause if I wanted to make certain columns exempt from the test. And if I have a look at my CSV files, this is obviously where I need to focus on getting my test data. So how do we get some test data into here in order to run a test? Well, I could just go in and type as if I was editing Excel. And speaking of Excel, I could also upload a file from Excel, a CSV file from Excel. If I didn't want to do that, I'm just going to discard that change. I could, I'm just creating quickly a temporary CSV file just to illustrate some points here. If I wanted to, I could go in and manually define, oh, sorry, I clicked on the wrong thing. I could use this fabrication capability. So MettleCI ships with something approaching 200 data fabrication functions that cover, come on fingers, I haven't had my coffee today yet, that enable you to fabricate a lot of very common data types. Just put a few in. Some of them have got parameters, street address, and let's have a phone number. That's boring. And you can, there are values here that, functions here that enable you to generate values between a range,
Join the meeting,
generate recent dates, generate dates in the future, iterate over lists of values that you supply randomly or in order. So there's some data I've fabricated. Let's have 19 more rows of that. And that's a very quick way of fabricating some data. In the future, if you have done some data profiling using Watson Knowledge Catalog and you have data classifications, then we'll actually be able to also automate the generation of fabricated data as well. So you won't have to tell us what function you want to use for each column. We'll pull that information out of WKC. But right now, that's not how I want to derive my data. If I go back to my DataStage job, I've actually got my favorite data set and my favorite kind of personal schema with my favorite 100 well-curated customers that I understand well and that I've been using for development for a long time. And what I'd like to do as a developer is to effectively use that data as the definition of the test and share it with other developers. So what I'm going to do is I'm just going to run my job as normal. But before I do that, I just want to draw your attention to something. If we look at the properties of the job and the parameters, there's one extra parameter that I've added to my job. You can either add this parameter yourself manually, or you can do it to an entire project en masse using a command. But it's actually an environment variable called DM enable unit testing. If we look at our environment variables, you can see that there's a MettleCI section in there now with an extra parameter. So that's the unit testing configuration. And what I'm going to do is I'm going to run my job as normal. And you'll see my unit testing configuration parameter has 3 values, which is disabled, which means don't do anything, just run my job as normal. We have test, which means execute a test case, but I don't have any test data yet. What I want to do is to select this mode here, which is intercept. So I'm just going to start that. And what that's doing behind the scenes, this is the last slide, by the way. What that's doing behind the scenes is at runtime, your DataStage engine is noticing that that job parameter and making a call to something called the MettleCI unit test harness. And so what the unit test harness is doing is, because I've set it to that intercept mode, it will actually sniff the data flowing into and out of your job at runtime, and it will capture a copy of those data into those CSV files. Then when I want to run a test, I'll rerun my job setting that test configuration value to test. And at that point, the DataStage engine will call the unit test harness again, and that will dynamically, in memory, rewrite your underlying job and inject the contents of those CSV files as sources into your job. It will similarly identify what data is being produced at the output. It will read those data and compare it to the CSV file we generated before, which represents our expected output. And that is a test. So let's go and see how our interception's gone. So we've run our job. It's just got a relatively low volume of data, as a good unit test should. And now if I go back and have a look at my unit tests here, I start clicking on some of these, we can see that I have actually captured some input data and also some output data. So I could just run this test, but it wouldn't tell us anything because of course it's going to pass because that's the data I just captured. What I want to do is I want to augment this with another test case, another row of data. So in true demo style, I've got an extra row of data stored there. There we are. I've just loaded in a version of this CSV file with one extra row on it, and I'm going to save that. And because I've added one more input row, I need to load in one more output row. And I'm going to save that. So now, if I run my job through using a new test, we'll get to see some test results. So I'm going to go to unit test configuration test. You may, the eagle-eyed amongst you may have noticed that we actually produced some warnings in the log here, just to tell you what's going on. So here's a previous warning telling us we were running in interception mode. Here's in the latest execution a warning to tell us we are running in unit test in enabled mode. And down the bottom, another warning to tell us that our unit test has failed. So our job has succeeded. It's green and data has been processed, but the unit test itself has failed. So if we go to Tools, Custom, Unit Test Result, that takes us back into the workbench, and we can indeed see that our TR orders has failed. And the problem is this extra row I added at the top, and everything's hunky-dory. Here's some of the test data that was supplied to me in the Jira story, and we can in fact see that 12.76 was expected versus the actual 12.75, which was delivered to me. So what I've actually done is I've created the test and got the test to fail, and now I will go and code to that test. So I'm doing test-driven development now in DataStage. So I'm going to go back into my DataStage job. I happen to know that the problem is with this rounding algorithm on this stage variable in this transformer. I'm going to OK that. I'm going to rerun my job again using the same test. Setting to test mode, run. And I'll just mouse over my browser at the bottom. I'm not going to open up that window or refresh it. We'll just have a look at what goes on in the background. RDP session didn't, I had some tearing, it didn't update. But the point I was trying to make there was that this unit test result window is automatically updated by your DataStage engine. You don't need to refresh your browser window. As a unit test goes green, so does this window. So I now have a DataStage job, which is, what I'm going to do is I'm actually just going to change the annotation on it. So when we see this job somewhere else, we know it's our job. I'm going to say hi, and I'm just going to bake that in. So I have a job now, which is compliant with our coding standards. I don't have any compliance breaches. We're not going to fail CI for that. I've got a unit test, which passes. And also I know that that unit test has a test case in it, a data row that represents the Jira story given to us by our business analyst. So I think I am good to check this into Git. So again, back in the workbench for the final time, it's got our context. I could add more assets to this commit if I wanted to, but generally one thing we like to do is to do one commit per asset, so I can give it a very specific commit message. I want to bring those unit test artifacts with me as part of this commit, so that YAML and the test data files are all going to get committed alongside my DataStage job. And by default, we want MettleCI requires that every commit is linked to at least one work item in a work item management system. So if you're using Azure, we want you to link it to an Azure work item. If you're using a GitLab, it's got to be a GitLab issue. You can link it to Jira stories, ServiceNow tickets, all kinds of systems we support. So we're using Jira, and I know that my story that I was working on had Jenkins. So I'll just type that in, and oh, dash, what's going on there? Oh, Larry, do you know anything about this? This is working fine yesterday.
No, sorry, not offhand.
Okay.
It was working for me too.
Yeah, strange. Okay, so I can't actually. So what should be happening here is we should be performing a dynamic lookup against Jira, but some things happened in the last 12 hours or the last 6 hours while I've been sleeping. And of course, that's one of the risks of a live demo. Occasionally something goes wrong, very rarely. Larry, would you be able to, if I take a very quick look at this, would you be able to share your screen and just take us through very quickly, just introduce the guys to compliance rules and how they're defined and what they look like? Have you got access to that stuff?
Yes.
Cool. If you wouldn't mind doing that, I'll just take
Sure.
2 seconds to try and work out what's going on here.
To bring up the right file. But yeah. It's going to be kind of not very exciting because it's going to be in Notepad, but yeah.
Do you want to just go to the compliance repo? Have you got the?
Yep. I'm pulling that up right. Oh yeah, that's probably a better way to do it. We'll do it from there.
Yeah, cool.
Okay. Okay, so I'm in Bitbucket, which is our interface to Git, but we support any interface you like, GitHub, GitLab, Git out of the box, ADOs, Git, anybody's, as long as it speaks standard Git. So here in this repo, we have our compliance rules, and let's take a look at one. How about default naming? Because we had a question in chat about default naming. These rules are written in a graph traversal language called Gremlin, which is something that comes out of the Apache project. And Gremlin supports your standard kinds of /* and / comments. And what's happening here is that this is mapping some information. It says basically that we are interested in the following kinds of stages that we're going to want to look at for their naming. And then after we go through all that, then we're actually in the graph traversal. And so what this is basically saying is, starting from the beginning of the graph, in order to run compliance rules, after we import the ISX, we build an in-memory model of the job that we can traverse. The stages and the edges that represent data flows are all represented as objects in the graph. And we actually have documentation on that. I was looking at that. Yes, here. This kind of explains the general idea that we take a job that looks like this, and we build a graph of it that represents the stages, their connections, and the metadata for the links and the stages. All right, and so then basically this looks like a Java / C++ kind of style language in that it has methods. So we can, for example, say for the item that we're looking at, if it's not null, then we want to do some checks, and then we will look for certain things in the name by doing a regular expression against the name of the stage. And if we find something, then we'll put a message out, and we'll carry on, and we'll iterate through all of the items in the graph until we have looked at every stage to look at its name. And then we do the same thing for the links. We traverse all the graphs, all the items in the graph for the links. If, as was asked in chat, if we wanted to change to say that we want the stage type as the tail end rather than the beginning end, it would be this regex that we would look for. This one is also doing a quick check to look for things like if we see a stage that has copy of in it, that's a sign that that this particular job might not be ready for prime time, because it might be a developer job that they were hacking around with some stuff. If we see something like has been deprecated, that's also going to cause us to throw up a warning. And so that's a general view of a given compliance rule.
Just to let you know, Larry, sorry that I'm all good now.
Okay, so I've danced long enough then.
Good deal. You did a beautiful dance. Thank you, Larry.
All right, brilliant. Carry on then. Please go ahead and take the share away from me, please.
Cool. I'm keen to get moving, so I want to get this Jenkins plan underway. Not that it takes a long time, but okay. So apologies for that slight hiccup, folks. I think I misconfigured my Jira last night. That's one of the symptoms of me being very, very busy at the moment, moving house, and I'm currently sitting here with boxes all around me, and it's been a tough week. So back to our check-in. What should have happened is that I type in a word into here, and it's just cached. So let me just refresh that, because I've just fixed something up. Take my unit test artifacts with me. And if I type into here, this performs a dynamic lookup against our Jira system and gives me the matching stories. So I'm working on MDP 43. I'm going to associate it with that one. I could add more here if I wanted to, but for now, I'm just going to link that one story, and I'm going to give it a frivolous commit message, although generally it should be better than that. And I'm going to check in. So again, we're exporting the job from XMeta. We're committing it to Git this time using what's called JGit under the covers, and we're done. So what's happening? Let's just get back to the main board in Jira. The first thing to notice is that our MDP 43 has a couple of changes. We've now got our commit message recorded as a comment against the Jira story. And you can also see now there are 7 commits against this story. You may remember there were 6 before. So if I click on that, you can now see there is our commit against this particular story. So I mentioned that we were using Atlassian Bitbucket. So if I jump on over here, I've got my Jenkins demos arranged into this project, and here is the repository that we're using. So this is our Jenkins demo going from DataStage 11.7 to DataStage 11.7. And here's the top structure of the repository. Let's quickly start by looking at our commits. There's our commit at the top. And let's have a look at our job. If I can find it. Oh, TR orders ISX. Yes, we use ISX format. And people say, why do you use ISX? It's the go-to format for information server artifacts. It's the only format that supports what we need to do from a compliance and a unit testing perspective. It's the only format that supports the full breadth of information server artifact. And you'll notice that for users of Atlassian Bitbucket, we actually provide a plugin to Bitbucket that enables you to visualize DataStage jobs actually in the Bitbucket interface. So you can see that's our particular job. If I go back to the previous version, we've got a different annotation there. So as I mentioned earlier, checking into Git's nice, but why do that? It's because we want to do continuous integration. So I'm in Jenkins now. I'm using the Blue Ocean interface in Jenkins. It's a little bit more palatable. And here's our build plan that's been invoked at the top with our commit message. So let's go off and have a look in there. So this is our build plan. And this build plan that you're seeing here is a plan that ships with MettleCI. You actually get this as a template build plan in order to start building your own pipelines. Excuse me 1 second. So what's happening at the moment is our job has been deployed into a dedicated CI environment. And by environment, I mean a dedicated CI project. What's actually happening is Jenkins is actually using an agent back on this particular client box that you saw me using earlier. So this DataStage environment here, this DataStage environment actually has running on it a Jenkins agent. So as well as me using this interactively, it's also being used as a kind of a robot for Jenkins to do what it needs to do. So our job has been deployed into a continuous integration project, and that itself constitutes a test. And being able to deploy and execute our job, it imports and our job imports and compiles. That itself is a test. And so we've passed that test. Then two other tests are occurring. We're running our static analysis. So our compliance rules have been run against that job. And then we're also running our unit tests against that job. And you may notice this reference to JUnit formatted test results. So all of the test results produced by MettleCI are exposed as XUnit or JUnit compatible test results. Which means that if you're using a higher order test orchestration suite like SonarQube or something like that, you can expose your MettleCI build results in those environments and start building test suites that track maybe the results of tests over time, or the trends, or identifying which particular jobs are have more flaky tests than others. If we look at the changes that have taken place, these are the changes that have triggered this particular build. You noticed that I checked into Git, and almost instantly Jenkins was invoked to run this pipeline. You can define something called a quiet time. So if you have a number of commits that all need to kind of be made in order to form a holistic solution, maybe I changed the definition of an output data set, added some more columns. And in order for my solution to hang together, as well as my job being checked in, all of the jobs that depended on that change also needed to be checked in at the same time. You can either make them all part of one commit, or you can check them all in within a few minutes of each other. And then you can configure Jenkins to say, hey, look, every time you receive a commit, start a timer. And if you then don't have any activity for X minutes, then you can treat that as a unit of work and then begin your pipeline. That's called a quiet time. So that was my change that triggered this build. I can see in my tests section that I have one test which was skipped. I have a job called TR purchase, which has a unit test on it, but that hasn't been executed. TR purchase wasn't part of the change set. So the last time it executed, it was successful, and nothing's changed since then. So there's no point re-executing that. However, we did check that our job compiles. We did run a test for each of our compliance rules that apply to this particular asset type. And then finally, our unit test was also executed, and that passes too. We're now performing our continuous delivery into the UA environment, and we can see that that's been completed okay. And we can see these pause icons over the performance of production environments. So if I click on one of those, this is where I now need to go and approve the deployment of that particular build to these environments. So it's already got all my values. You notice we've got this environment identifier here, and I'll talk about that in just a second. But right now, I'm just going to click yes. And the blue ocean interface can be a little bit strange. I'm just going to refresh that to see if it picks up my click. Yes, it did. Okay, and so what's happening now is that same build is being deployed to the performance environment. And this process, by the way, is exactly how you would roll back releases as well. So I'm on release. You can see this is build 112. If I go back and look at my pipeline history and someone says, everything after release 95 has been a disaster, you need to roll back production to release 95 immediately, I can just jump into release 95 and I can restart the promotion here. And so I can effectively re-release old releases into whatever environment I want to. But we'll stay with our current one. We're currently now deploying into performance. Now, I mentioned that environment identifier. I could, if I wanted as well, run into production at the same time. But that environment identifier, if we just go to the root of our repository, I just want to talk about the structure of this for a second. You'll see that in this repository, we've actually got some compliance rules. You can either keep your compliance rules in a separate kind of cross-organizational repository or in your DataStage repository. It's kind of up to you. Or you could have a hybrid and have a sub-repository. In this case, we've kept them in the DataStage project. This is our DataStage solution here, and the structure under the DataStage keyword, the structure of the repository here is maintained by MettleCI for you. You don't, if you create new categories, you don't need to go and create folders in here. That's all looked after for you. You got your file system artifacts, your unit test artifacts. There's our TR orders unit tests. But at the top level, there's our Jenkins file. So this is the source of the pipeline that's being executed by Jenkins at the moment. And I'm flicking this stuff because it's all in our documentation, and I'll give you a link to that shortly, or Larry can pop on in the chat. But you'll see there are these var files, var.ci, var.perf, var.prod, and what these are variable override files. So as part of MettleCI's deployment process, we do some smart things around deployment. When we're taking a change from Git and deploying it into a CI environment or QA prod or perf or whatever your environments are, we do a number of things. Firstly, we run that process in a multi-threaded manner. So if you've got a large number of changes in your change set, we'll run all of the imports and the compiles in parallel. Up to a particular threshold in order to maximize the use of your resources. We'll use these var files to perform variable substitution. So we often see customers overloading their parameter sets with all of the different connection credentials to all of their environments. And that's a bad practice. What you can do here is just build one set of parameter set values, and then as part of our deployment process, we will effectively perform key value substitution based on what is being found for the particular nominated target environment. So here we're dynamically replacing some variable default values with these values stored in this file. That means you can keep all of your credentials for an environment in one place and not have them littered throughout multiple jobs. Also with deployment, we identify dependencies and dynamically recompile them. And what I mean by that is if you were to take, for example, if I just checked in a shared container as part of deployment, we will identify all of the jobs in the target environment that use that shared container and dynamically recompile those. Because of course, the contents of a shared container are statically bound to the job. They're compiled in at compile time. Finally, we'll also we use something called fingerprinting. So one of the things that you often find is that a developer might jump into a downstream environment like UAT or perf, and in order to diagnose a problem which can only be seen in that environment. And so they'll often add a bit of instrumentation to their jobs to say, okay, let's add a peak, or let's dump out a file, or change the functionality of a job just to try and understand the nature of a problem. That's fine as long as you can guarantee that job is then reset to its proper Git golden copy at some point in the future. And that's what we do. Even though I've just deployed TR orders downstream into these environments, if as part of the deployment to the performance environment, we'd also identified that TR purchase had been changed by someone and no longer represented its version in Git, we would identify that and automatically redeploy it in order to say that when we have deployed to performance, that environment looks exactly like the Git repository. It's prompting me to deploy to production now. I might as well go ahead and say yes to that. Larry's covered the compliance rules and the gremlin stuff. I know you jumped into one. Let's look at a simple one. I don't know if you pointed out, Larry, we've got parallel and server equivalents for most rules, and for some the PJB and the SJB, and for some of them we also have the QJB. That's the job sequences. And a very
sorry,
simple
I
rule.
forgot to point that out.
No problem. And just a very simple rule. Just this isn't a proprietary language. It's an Apache language. It's used by Watson Knowledge Catalog as well under the covers to do its stuff. But essentially, we're looking for a stage that has a type of transformer with an output connected to a stage that has a type of transformer. So this is looking for two adjacent transformers in a job. If you find that pattern, deduplicate it into a single error, and then fire out a compliance message. So Jenkins is busy finishing. Our Jira story is up to date with the commits and the comment history. And time-wise, I think we should probably get on with seeing if we've got any outstanding questions we haven't touched on.